We are going to start by talking about something called antiderivative. What is an antiderivative? So if a function is given to us as, let's say, 3x squared plus 1, and we are asked to find its derivative, no biggie. I have 6x because 1 prime is 0. So given the function, if I'm given the function, I can find the derivative. But now the question is, if I am given the derivative, how do I find the function? So that's the idea now. So if I try to find the function, it means that I'm finding the antiderivative of this function. So I'm looking for uppercase f of x or lowercase f of x. And you can say, wait a minute, what's the connection? Well, what's the difference? This one uses an uppercase f and this one uses a lowercase f. Who cares? Well, it's an important notation difference. So if we are given f prime of x, we will determine f of x. If we are given f of x equals 6x, we will be asked to find uppercase f of x. Okay? And the difference is based on a theorem. And the theorem is called fundamental theorem of calculus. Fundamental theorem of calculus. So for now, let's say we are given f prime of x, which is 6x. Because I'm given the notation f prime, I will determine f of x. And how do I find this? How do I find the function whose derivative is this? Well, I go backwards. Well, how do I go backwards? So let's first of all discuss about x in general. So remember when we differentiated x to the nth power, you always told me x times x, n times x to n minus 1. But now trying to go backwards, if I want to get x to the third, how do I get x to the third? By differentiating x to the fourth over 4. Where does this come from? Okay, so let's check. Bring down 4 when I differentiate. Bring down 4, simplify, and subtract 1 from the power. So I will copy 6. X to power 1 means it's coming from x squared divided by that number, 4 over 4. How come? Well, when I differentiate this, I bring 2 down, simplify, and I get x. And then plus a constant c. Why? What's this? Well, a constant prime is 0. So what did I get? I get that f of x, after simplification, is 3x squared plus a constant c. This is called the most general antiderivative. Of f of x. I meant to say f of x equals 6x. It's a family of functions. A family. Because c can be 0, c can be 1, c can be negative 3, c can be negative 1500, c can be positive 1,000,000. So that's why this is called the most general antiderivative of the function we started with. But then you can say, wait a minute. You talked about this function. You didn't get that. Oh, I got that and million others, infinitely many. So this function is the derivative of infinitely many functions, because C can be anything. One particular one is this one, the 3x squared plus 1, if C is 1. But if C is 5, that's another one whose derivative is 6x. If C is whatever number you want, the derivative will still be 6x. So this is called, again, the most general antiderivative of the given function that we started with. It's a family of functions. Many functions have the same derivative. Okay, that is our first step to understand what antiderivatives are. So here's an example. Now let's say we have f of x equals e to 3x plus 4. We are given this function, and we are asked to find the most general antiderivative. Okay, fine. Because the notation is f of x, I will have to use uppercase f of x as the notation for the most general antiderivative when the function is given to us as f. Now, the question is, what function prime is this? Well, it's e to the 3x divided by 3 plus. Can anyone tell us what function prime will be 4? And then I'll come back to this and explain this again. What function prime is 4? Can anyone think of a function? You mean 4x. 4x prime is 4. And yes, you're right, plus a constant c. And before I explain this again, I want to talk about this for a moment. When I differentiate e to 3x, please, I hope you remember that e to 3x is e to 3x multiplied by 3. Therefore, when we divide by 3 and we differentiate, the 3 will go away, and I get back that. So remember, f, the derivative of this function is that function. So when I differentiate this, I get e to 3x. When I differentiate this, I get 4. When I differentiate this, I get 0. Where is the 0? Right here. 0 is always everywhere. So this is the most general antiderivative of this function, e to 3x plus 4. In other words, I'm saying many functions have this derivative. Many. Okay. There is a notation, which in my calculus classes, not in this class, because the book shows it like that, so I try to keep up with the book, although I disagree with it sometimes. They're using already a notation that I normally do not introduce in 4.1, do not, in my regular calculus classes, but I'll do it now because it's in this section. So when we try to determine antiderivatives, we have a second notation. And the notation is basically letter S, but stretched, elongated. So instead of normal S, we write it like this. It's a huge difference, but that's what it is. It's basically a sum. I will get to explain what the sum is coming from. So if I try to find this sum of e to 3x plus 4, parentheses around the function, times dx. Dx is the differential of x that we talked about in the previous chapter. The answer is this. It's a different way of writing or saying, find the most general antiderivative. I know you cannot understand what the sum is coming from, but I will explain it in the next section, and you will understand this. But just remember that this is the letter S stretched to the maximum, elongated if you want, the function, and then dx. Because remember, dy is f prime of x dx. That's the differential of y, f prime of x dx. That's what this is. So then the answer is just that, e to 3x over 3 plus 4x plus a constant c. How is this called? You can say it's the most general antiderivative, yes. But also by itself, it has a name. And the name is the indefinite. The indefinite, not indeterminate, not undefined, indefinite integral of e to 3x plus 4. The indefinite integral of e to 3x plus 4. What is it? The most general antiderivative. Of which function? Of this one. It's a different way of writing it or using a different notation, in other words. What's the notation? The indefinite integral of e to 3x plus 4 dx. The indefinite integral e to 3x plus 4 dx is nothing else but the most general antiderivative of this function. I'd like to stop and look at some problems in the book. And I let you choose. I'd like to practice this notation now. So I'm almost there. My apologies, I was working with a student from my Calculus 2 class and I did not get the chance. I have the calculator ready, but I did not get the chance to open Pearson. So we are in chapter 4, section 4. We are in chapter 4, section 4.1. And we are talking about antiderivatives, the most general antiderivative. And sometimes we will find a specific function, one, and we'll see when some conditions are given. I don't know how I got here, but I hope to get where I'm going. To get to where I'm going, please. Okay, and I want page 392. 392. So for now, let's choose from 5 through whatever you want, 46. Allow me to choose the first one, and then you choose the rest. I would like to choose 9. And then please feel free to choose. The indefinite integral from 2t squared plus 5t minus 3, since the function is in t, I have dt. If the function is in x, I have to have dx. But the function is in t, so then I have to have dt. The indefinite integral of 2t squared plus 5t minus 3 dt. Basically, find the most general antiderivative of this function. Okay, fine. We take it piece by piece. 2 stays outside. Which function prime is t squared? And remember the rule. We increase the power by 1 and we divide by that number. So t squared. We increase the power by 1, and we divide by that number, plus 5. Can anyone help with t? Which function prime is t? Anyone please give it a try?
2t divided by t.
T squared divided by 2. We increase the power by 1, and we divide by the resulting number. Minus, which function prime is 3?
3x.
Yes, 3t. Very good. Perfect. Yes, x or t doesn't matter. But since we have t, we have to write t. Plus a constant c. This is it. How do I check my answer? Very easy. I differentiate this, 3 simplified, and I get 2t squared. I differentiate, simplify, and I get 5t. I differentiate this, I get -3. I differentiate this, I get 0. This is it. So the indefinite integral of this dt is 2/3 3 cubed plus 5/2 t squared minus 3t plus c. Yes, I know you don't understand why we're doing this yet, because this is not the correct order, but I have to do it. I will do it like it is in the book so I don't confuse you. You still don't know why, but it will become very clear soon. I promise you why we're doing this and why we need to go backwards. Here's one explanation. So for example, if I have a formula for the velocity, which is the derivative of the distance, I can use this procedure to find the distance function. From the derivative, I can find the function. If I have the acceleration, is the derivative of the velocity, and I can find the velocity. I have the derivative, I find the function. I have the derivative, I find the function. I have the derivative, I find the function, or the family of functions. So for now,